Сьогодні ми маємо честь послухати лауреата Нобелівської премії з фізики 2014 року, професора Нагойського університету та університету Мейдзі, професора Амано, який презентує лекцію на тему «Якщо ти стаєш Нобелівським лауреатом». Хочу проговорити декілька технічних моментів для того, щоб всім було зручно і комфортно під час нашої лекції. Мікрофони всіх учасників вимкнені автоматично. Всі питання, які у вас виникатимуть, ви можете писати в чат. Наприкінці лекції ми виділимо 20-30 хвилин на сесію питань-відповідей, і ми з моїм колегою Дмитро зачитаємо всі питання. Мене звати Валерія, я буду модерувати цю сесію разом з моїм колегою Дмитро. Якщо у вас виникатимуть якісь питання, можете писати нам в особисті повідомлення в чаті. Також рада вам повідомити, що наша лекція матиме синхронний переклад. Внизу в панелі між записом і реакціями у вас може бути такий, як планета намальована. Ви можете обрати англійський оригінальний виступ слухати від професора Амано або переклад від нашого перекладача Богдана. Дуже вам дякую, що допомагаєте і зголосились нам забезпечити такий переклад. Якщо у вас виникатимуть питання, ще раз наголошую, пишіть, будь ласка, в чат або технічні труднощі. Всіх ми будемо доєднувати. Якщо когось виб'є з, наприклад, з Zoom, у вас, будь ласка, доєднайтеся за тим же посиланням, протягом хвилини-двох вас доєднають. Запис лекції буде розміщено на каналі Малої академії наук в YouTube. So, dear Professor Amano, good afternoon again. On behalf of Junior Academy of Sciences of Ukraine, I'm happy to welcome you to our project Lectures of the Future. Thank you very much for joining and presenting your master class for Ukrainian students and school students. It's a very great honor to give you the floor now, so please start. We are happy to hear your presentation.
Okay, thank you, Valeria, for the introduction. Good morning or good afternoon, everyone. I'm Hiroshi Amano, Nagoya University. Thank you so much for giving me this chance. But before starting my talk, I also prepare the movie for my mentor, Professor Makasaki's story for you. So if you are interested in, please visit the address using this QR code. Okay. Привіт, українці. Is that correct? I'm sorry, I can't speak Ukrainian, so I have to speak in English. What I can do for you is almost nothing except for explaining my experience, how I became the Nobel laureate. So I hope my talk will encourage you to become the Nobel laureate. My story is based on, it's a bit difficult to understand that, but it is light emitting diode, LED. What is LED? Maybe you can see the blue light or red light, green light in the Christmas tree. In the Christmas tree, there are a lot of LED lamps like this. And LED itself is a very, very small chip like this, okay? And there are several requirements for bright LEDs. That is the crystal, good crystal. In case of blue LEDs, we need a gallium nitride, GaN crystal, okay? And also we need N-type, negative type, and positive type, N-type and P-type gallium nitride. And also we need the blue luminescent material, okay? What determines the color of LEDs, light emitting diode, by changing the composition of the elements, gallium, indium, and phosphorus and nitrogen. We can control the wavelengths of light. If we compose indium gallium phosphide, we can realize red LEDs. And indium gallium nitride, by controlling the indium and gallium composition, we can control green or blue LEDs. And N-type, negative type, indium gallium nitride is rather easy, but positive type, P-type gallium nitride was very, very difficult. To realize P-type indium gallium nitride, we need additional element, that is magnesium, okay? And this slide shows the history of artificial lighting. By 19th centuries, the fire is the only artificial lighting. It's based on the chemical reaction. It's an oxidation of carbon hydride, okay? And 1878, incandescent lamp was invented by Joseph Swan or Thomas Edison. This is called the black body emission. Okay, it's an early stage of quantum mechanics. In 1926, fluorescent lamp was invented by German physicist. It's a third generation artificial lighting, okay? But as you see, the glass tube was very, very fragile. So the LED is thought to be the ultimate light source because it is based on quantum mechanics, and also it is a very solid material, okay? Operating principle of incandescent lamp is a black body emission. In any material, if the temperature becomes high, it emits light, okay? However, this is the visible region, but majority of the emission is out of the visible region. It's infrared, so it's very warm, but it's not useful for the artificial lighting. So efficiency is very low. And also the lifetime is very short. Fluorescent lamp, the operating principle is the accelerated electrons excite mercury vapor, which emit deep ultraviolet light. But deep ultraviolet light cannot see, for human, people cannot see the deep ultraviolet light. So we need to change the color from the deep ultraviolet to visible light. So phosphor is used to change the ultraviolet light to visible light, okay? However, there is a called the loss, called the Stokes shift loss. So the efficiency is still limited to be not so high. In comparison, in case of LEDs, the operating principle is only a energy transfer or the recombination of negative carrier electrons and the positive carrier holes. Okay, so the efficiency is very high, over 200 lumens per watt. That's why the LED is so promising. However, it was very, very difficult to grow high crystalline quality gallium nitride. To grow gallium nitride crystals, we need very high pressure, 45,000 atoms, and a very high temperature, more than 2,000 centigrade. So we have to grow LEDs on the falling material like sapphire. However, the atomic arrangement of sapphire and gallium nitride is quite different, over 16% mismatch. So no one could grow high quality gallium nitride crystals, okay? And also, responsiveness of human eye is very low in the blue region. Compared with the yellow-green region, it's about 3%, okay? So the responsivity of human eye is very, very low in the blue region. So my mentor, late Professor Samakasaki, continued to develop the blue LEDs for more than 20 years at the private company, and then moved to National University, Nagoya University in 1981. And I joined his group as the undergraduate student in 1982. When I saw the graduation research, nitride-based blue LEDs, I was so excited because at that time, I was interested in the microcomputer system. And in the microcomputer system, the brown tube was used as the display. The very old display was like that. It's very big, huge. So if I could achieve the blue LEDs, I would change the world by realizing like a smartphone. That's why I could concentrate on this research subject. The insufficient research fund of the university in Japan laboratory, the research fund was US dollar 30,000 per year, 30,000 per year for more than 10 students. So we have to divide it into a very small amount of the research fund. So the student should develop the crystal growth equipment by ourselves, okay? It's called MOVP, metal organic vapor phase epitaxy. And yeah, the beer bottle is not for drinking the beer, but to make an RF coil for heating. In such a way, we developed our MOVP reactor by ourselves. It's a handmade reactor. Okay. If we purchase this equipment, we need at least $1 million US. But the research fund was very, very limited. So we developed our own equipment, less than $30,000 US. Okay. So I concentrated on trying to grow high quality gallium nitride crystals more than 1,500 times, but I could not get high quality gallium nitride film for 3 years. Undergraduate student, master course first year, master course second year. No success. However, I enjoyed such a situation because in the previous stage, all the experiments were prepared by other people. But in this case, I could do by myself with my equipment. That's why I could enjoy such a situation and continue the experiments every day, more than 5 times per day and 365 days. Oh, thank you so much for the questions. From Mikhail Dudo, can you predict what will be the 5th generation of LEDs? Yeah, thank you so much for the very good questions. Yeah, there are several candidates. One example is organic LEDs, which is very, very flexible. Still, the efficiency or the lifetime is limited, but flexibility is one of the possibility of the 5th generation LEDs. Okay. Oh, there are many questions. Okay, where did you get the electronics for MOVP reactor? Huh? Just a moment. I wasn't the first one to ask that question. Thanks a lot for. Hera, do you have a dream? What is your dream? Do you love money? Money. Okay. Money is also, of course, the money is one of the dream, but not the only one. Okay. So after 3 years of struggle, I succeeded to grow world's highest quality gallium nitride crystals. There was a very good hint from the Professor Sawaki, at the time associate professor of Akasaki Laboratory. Oh, okay. What was the cause to develop LEDs? Why we need LEDs? Yeah, that's a very important question. The LED development is very important to realize. Maybe you're using the smartphone or, okay. So in the smartphone, there is LEDs, blue LEDs and red LEDs. Huh? What helped you to overcome all the consequences? Was it just pure motivation? Oh, that's also very important. Okay, yeah, my first motivation was to develop the blue LEDs for the smart displays. However, the problem is I have to get the PhD, okay? I have to get the PhD. To get the PhD, I need to write at least 3 journal papers, okay? Oh yeah, it's okay. If you have any question, please interrupt me. No problem. Thank you. And then I achieved the world's highest quality gallium nitride at the time. I wrote the journal papers, and I thought I could become the very famous researchers. However, it's a mistake. My paper did not take notice of other researchers. The reason was at that time, almost no one was interested in the gallium nitride. Other researchers are interested in the zinc selenide like this, other materials. So I could not become the famous researchers. However, I have to get a PhD, so I should continue my research. There is another question. Have you dreamed of becoming a scientist since childhood? No. When I was a child, I want to become the professional baseball players. What type of phosphor did you choose? Okay, great. I'll show you later. Oh, there are so many questions. Okay. Okay. Anyway, I'd like to continue my presentation. Yeah, I should overcome the
questions to the end.
Okay. I should overcome the second barriers to realize P-type gallium nitride. At that time, very famous researchers all over the world thought that P-type gallium nitride was impossible because of the self-compensation. Self-compensation means that if we input acceptor impurity for P-type gallium nitride, automatically a donor level is formed, which compensate the acceptor. Therefore, P-type gallium nitride cannot be realized. But my impression of a self-compensation was only a pro excuse of the non-completion of P-type. So I concentrate on to realize P-type gallium nitride during my doctoral courses 3 years without any success. Okay. However, I found a very interesting phenomena during my internship at NTT. I found that by electron beam irradiation, blue luminescence was reversibly enhanced. So I presented this result. We call it the Revit treatment at the International Luminescence Conference, which was held in Beijing, China. I believe that I was the first person to find this Revit effect. But when I checked their previous studies, I found that Moscow University students, Dr. Saparin, already found the same phenomena 5 years ago. So I could not write the third paper for doctoral thesis. So consequently, I could not finish doctoral thesis in 3 years. However, Professor later Kasaki allowed me to continue research after finishing doctoral courses. During my doctoral courses for 3 years, I concentrated on seeking P-type gallium nitride, although all the efforts were fruitless. So I could not get PhD in 3 years. However, I was very lucky that I could continue research as a research associate by the support of Professor Isama Kasaki. Then, after 4 years from the start of P-type challenge, I found my mistake. I used zinc as the accepted dopant, but magnesium should be better. Okay, magnesium should be better. So I switched from zinc to magnesium, and then by repeat treatment, I finally realized P-type gallium nitride and the PN junction LEDs. Okay. We have the crystal growth equipment, but we couldn't have the repeat treatment equipment. So using the very small scooter, 1 hour, I went to the research partner to the Gosei, and it took 7 hours. And then went back to Nagoya University. So for one sample, I took 9 hours. But at that time, I have to get the PhD, so 9 hours is no problem. Then I could realize the PN junction for the first time in the world. So in 1989, I appeared in the newspaper behind Professor Isama Kasaki. Here, the Professor Isama Kasaki and me. It's in the Junichi Shimbun. It's a local newspaper. The reason why the blue LEDs was so important is, do you see this right?
Yeah, we see.
By adding this yellow film, we can easily realize the white light. So white LED light is composed of only blue LEDs. Okay. That's why the blue LED was so important. Oh, someone have trouble? Okay. Okay, then 25 years have passed. Let me explain what had happened in 2014. I was aged 54. The Nobel Prize award ceremony is always held in December 10th. It's an anniversary of Alfred Nobel's death, okay? And 2 months before, which means the October, in the early October, the announcement is held always, every year, okay? And before two weeks before the announcement, our group went to the laboratory trip near Mount Fuji. So please remember this photo, okay? In the morning of October 7th, I went to France. The reason is, Professor Kasaki was very famous. He has been nominated as the candidate of Nobel laureate for more than 10 years. And Professor Shuji Nakamura, he was also extremely famous. However, this person is nameless, okay? So every year in early October, many journalists came to our office and waited for the announcement of Professor Kasaki's winning Nobel Prize. And always, every year, a journalist requested me to give them very nice comments when he received the prize. The first year and the second year, I enjoyed such a situation, but after 10 years, I was tired of such a situation. So I decided to go abroad without informing to our university. Announcement was held during my flight. And when I reached the Frankfurt, it was transit. I opened my PC and I found that there are so many emails entitled congratulations or omedetou gozaimasu in Japanese. However, no one wrote why it is so happy. So I couldn't understand such a situation. And I thought, oh, I should never receive such a large amount of email. So it should be they should be a spam mail. So with fear, I went to the final destination, Lyon, and found that many journalist-like people waiting for someone. So I thought, oh, I am lucky that some famous movie star is coming with the same flight. But who? Then one of the journalists came to me and said, are you Mr. Amano? You received the Nobel Prize. Wow. The problem happened in my university. Mass media interviewed my laboratory without me. So this is my photo, okay? And also, I was missing at the press conference in our university. Okay, that's the whole story. So finally, I'd like to send a message to you. If you become the Nobel laureate, you will keep the Ukrainian tradition and build a new Ukrainian. So you will consider what you should do, not only based on your curiosity, but also your role in society and for the earth. We are always on your side. God bless you, Ukraine. Thank you so much for your kind attention.
Dear Professor Amano, thank you very much for your presentation. And we have several questions. So, yeah, Mr. Nazar asks, do you read business books and what books you can advise?
The books?
Yeah, oh. Business books.
Business books, oh really? Yeah. There are so many business books, but yeah, do you know the 7 habits of highly
effective people?
Yeah, 7 habits of highly, I forgot the title, but there is a very informative books. The 7 habits of highly effective people. Yeah, this book is very informative and become a very effective people.
Okay, the next question is from Tatiana. So Professor Amano, do you have any ideas for improving leads? How do you think you can make them practical?
Oh, the improvement of the efficiency of LEDs, okay. Now the efficiency of blue LEDs reach almost the maximum, over 80% efficiency is already realized. So it is not so easy to improve more. However, still we are facing the very serious problem of the ultraviolet or deep ultraviolet LEDs. for attacking the coronaviruses. Okay, for coronaviruses, we need LEDs with wavelengths of 265 to 220 nanometer. The efficiency is still limited to be less than 10%. So we are trying our best to improve the efficiency of the deep ultraviolet LEDs, especially for attacking coronaviruses. Okay.
Another question from Tatiana as well. What can help you during a work? Maybe music, nature sounds, podcasts?
Oh, my case, the sleeping. Sleeping helps me to recover my energy. Okay.
So another one question from Alina. Do you have any favorite hobbies?
Hobbies. Yeah, I have several hobbies. Especially I like sports, the soccer and the baseball and the climbing mountains or the swimming.
Okay, another question from Daniela. Do you believe in modern generation of scientists? Do you believe in modern generation of scientists?
The younger generation, you mean?
Yeah,
or?
yeah.
Yeah, of course. Yeah, that's why I joined this meeting. I believe the potential of the young scientists or all of you. The reason is the elder person have have the very low power of innovation, or to become the inventors. You should do when you are young. If you become elder, the power of invention becomes lower and lower. So you should do now, not in future. Okay.
Okay, another question from Alina. What motivated you to make this invention?
Oh, yeah, that's a very important point. I want to be the, I want all the world becomes the peace and safety. Okay, so I am now concentrating on the developing new types of devices by which we don't need to worry about the oil, or we don't need to worry about the gases or the coals. By using a new devices, we can get energy from the solar or from the wind. That's what we are now concentrating on.
Okay, we have another question. What source of information have you helped you the most in the research? Can you advise some literature?
Oh, that's also very important. Yeah, by checking the SNS or the newspaper, I can get the information what we should do now. For example, the energy deficiency or food deficiency or water deficiency. So I, as one of the researchers, we are trying to develop a new system for provide the safe water, safe food, or sufficient food, or the sufficient energies. Okay.
The question from Roman, do you have some favorite scientist, and who is it?
Oh, favorite scientist, okay. Yeah, when I was a child, I liked like Einstein. But now, I like some business person like Stephen Jobs or
Okay, and the connected question from Angelina, what inspires you to make science? What is your inspiration?
Oh, inspiration. Of course, inspiration comes from the class or lecture in the school, but mainly now I got information from the, for example, Yahoo or internet.
And maybe also connected question with the previous one from Sophia. Didn't you want to give up when you were doing work and you didn't succeed, and how you coped with it?
Oh, okay. Yeah, sometimes we are facing very serious research subjects, which I could not solve it immediately. But in such a case, we have to take a long time to overcome the problem. So in such a case, my case, the sleeping is a very good method to recover my energy. Okay.
Okay. Maybe then another one question. Who was your best mentor or teacher in your life?
Oh, yes, of course, Professor Isamu Kazaki. He unfortunately he passed away the last April, but without him, I could not become a researcher. So Professor Isamu Kazaki was my best mentor.
Okay. Very surprising question. Do you ever wanted to go to space?
Space? Oh, really? Yeah. I don't want to. Oh. The on the Earth is enough for me.
Okay, maybe another one question about the motivation. How did you know that you wanted to become a scientist?
Oh, become scientist. Yeah, it's I did not want to become a scientist when I was young. I want to become the baseball player when I was a child, and I wanted to become some book writer. Okay, when I was a high school student. The reason why I became scientist is when I entered the university and I found the blue LED research. That's why I became the scientist. So, yeah.
Okay, thank you. And another question, what project are you working now on?
Oh, thank you. It's very important. We are working on the very efficient electricity circuit system, and also very high power microwave and millimeter wave amplifier for beyond 5G and beyond 5G wireless communication and the wireless energy transfer. Okay. We can transfer not only the signal, but also the electric energy using the microwave or millimeter wave. So we are concentrated on developing a new generations wireless transmission system.
Okay, question about the Nobel Prize itself. What did you feel when you were rewarded a Nobel Prize?
Okay. The first time I found that I received the Nobel Prize was just in the Lyon airport. So only thing that I could do is the surprise. I couldn't consider anything but to surprise.
Wow. The question from Alina, what can you advise to a young generation, to young scientists, to become as successful as you are?
Oh, wow. What I can send to you is to concentrate what you are interested in. The reason why I could continue the research of blue LEDs was I was interested in very much. So I hope that you find some very interesting thing, and if you can concentrate on it, you will become the very good scientist in future.
Okay, now we have a question about your lecture from Valeria. At the beginning of the lecture, you talked about the results of reactions of phosphor with some chemical elements. What kind of phosphor did you mean?
Oh, phosphor. You mean this one? This
Probably,
is one of the phosphor. Yes, by adding the blue LEDs, we can easily realize the white LEDs. This phosphor is based on the YAG, the material called YAG, yttrium aluminum garnet. It's a little bit complicated material, but this material is very, very efficient, very, very useful to transfer the blue light to yellow light. So then we can realize the white light by mixing blue light and yellow light. So this material is composed of yttrium, aluminum, gallium, garnet. Okay.
One more question about the motivation and Nobel Prize from Lyubov. What is the most important thing to win the Nobel Prize?
The most important thing is the continuing effort of what you are interested in. You should concentrate on the what you are interested in. This is one thing. And the second thing is, if it is possible, it should be, or it would be better if it is very useful to all the people around the world. For example, the blue LED or LED lighting for efficient lighting system, something like that. If it is useful to environment or the earth, it is more, it's really much more better. Okay.
The question from Diana, what do you dream about now?
Now?
Yeah.
No. Yeah, I want to visit Ukraine and discuss with you. That's my dream.
Okay, the question from Paulina, dear Professor Amano, do you have a favorite quote or motivational phrase?
Oh, phrase?
Yeah, motivational, maybe some, I don't know,
motivation.
some statement you inspired.
Oh, that's, what's the motivation? The motivation for the people, not for me. Yeah, I want to become like a Superman for other people.
Okay, the question from Arina, what do you think is the most important to be a good scientist?
Oh, that's also very important, but difficult to answer. to be a good scientist, you should never surrender. You should continue your research until you reach the goal. So never surrender.
The question is about phosphor. We come back to the previous one. So is it dangerous to work with this material?
Dangerous?
Oh. Is it dangerous?
Yeah. In case of gallium nitride, we are using metallic gallium and ammonia. Ammonia is not so dangerous, but sometimes the smell is very strong. And but the reaction itself, we need a high temperature, 1000 centigrade. So it is not so safe if you touch it or something like that. But if you keep it out from the reaction, it's very safe. And the gallium nitride itself is no problem. Maybe you don't drink it or eat it, but even though if you eat it, no problem. Okay.
Okay, we have several questions actually about did you have people who didn't believe in you and in your success, and how did you react and cope with it?
Oh, the people who doesn't believe me.
Yeah, in you and in your work and in your success.
Wow. Oh, that's very difficult question. The most efficient one is to show our results. To show a result like this. That's very, very the result explained everything.
Okay, and maybe connected question. What did you say to yourself in moments of failure or when you give up or some bad situation happens?
Okay. Yeah, of course. I was not always successful. There are many failures. In case of crystal growth of gallium nitride, I failed more than 1,500 times. But the reason why I could continue is I was interested in by doing by myself. That's very important. If the equipment have been prepared by others, maybe it was difficult to continue. The reason why I could continue is because I developed our equipment by myself or by ourselves. So do it by yourself is very important, I think.
Okay, and maybe the last question, we have several similar questions. Why did you decide to become a physicist? Why have you choose physics as your major?
Oh, thank you so much. Yeah, the reason is I could continue it because before I met with the blue LEDs, I didn't think that I should become the physicist or scientist. The reason why I could continue as the scientist is because of meeting with very exciting, very important, and very interesting research subject. Okay.
Okay, I want to thank you for your presentation and all questions you have answered. I hope that our participants and young scientists will inspire and will continue their pieces of work. of research, and we'll raise up your topic, and maybe one of them will receive some prize in the future.
Yeah, of course. I hope so.
Thank you very much for joining the Junior Academy of Sciences of Ukraine and the project lecture, The Future. I wish you good luck and success, and thank you for all participants for joining and asking the questions.
Thank you so much.
Thank you.
Have a good day.
Goodbye.
Bye.